Hello! Welcome to this physics nugget, which is all about radioactivity. Now, radioactivity is a core topic in most GCSE science or physics, and yet there is a problem with teaching it, which many science teachers have expressed to me, and that is that many schools do not have radioactive sources available. Now, to my mind, this is a great shame, but there it is. What can we do about it? Well, we can teach out of the textbook, we can do some simulations, but it would be great, wouldn't it, to actually demonstrate something practical to our pupils. And this physics nugget is going to show you how to do that using only two things, your Geiger counter and the balloon. What are we going to do? Well, we're going to first of all take a background count here. Here's my little GM tube. I'm going to take a minute's worth of readings. Background radiation. I always like to tell my pupils, be specific about the sources of background radiation. Don't just say the sun, say cosmic rays from the sun and from outer space. Don't just say rocks and building materials, say uranium compounds in rocks and building materials which produce gamma rays. Don't just say carbon-14, say carbon-14 in the air and in our bodies, although actually carbon-14 isn't a very big source of background radiation. Others are more important, and one of the most important is radon gas. Radon gas in the air is probably the largest source of background radiation. 3, 2, 1, go. Here we go. There we are. 17 counts in a minute. That is fairly typical for here, but you may have a different kind of geology in your area, which means that, so in Cornwall, the background radiation is probably a bit higher than that, but 17 is fairly typical for here. Now, I'm going to blow up this balloon. And I'm going to rub it on my cardigan, my polyester cardigan. If you've got lots of hair, unlike me, then you could use that. Now, this is just frictional charging of the balloon, like for that demonstration where you stick it to the wall. And I suppose it would be a good opportunity to revise that, but the important thing is simply that the balloon has been charged, and I'm now not going to tie it up, I'm just going to hang it in this bulldog clip here. I'm going to just clip it on here, and hopefully it should sit there for about 20 minutes. And as it sits there, because a charged object will attract little neutral objects like dust from the air, it's going to accumulate dust on it. Now the point is that this dust contains decayed products of radon. Radon-222 is an inert gas, but it decays into other things like polonium-218, lead-214, bismuth-214, which are not gases, and they will remain in suspension in the atmosphere. They'll stick to little particles of dust, and the balloon's going to attract them, and it's just going to sit there attracting it for the next 20 minutes. So we shall see what we shall see. Right, as you can see from the clock, it's about 20 minutes later. I'm going to let the balloon down gently. That's so that I don't knock off any of the dust. Remember, this balloon has been attracting dust from the surroundings which is going to contain radon decay products, primarily lead-214 and bismuth-214. Now, what we're going to do is we're going to scrunch the balloon up so that the dust is concentrated, yeah? And I'm going to squidge it up into a small packet, and I'm going to place it as close as possible to my GM tube like that, yeah? And then we're going to take a minute's count again. Right, already you can see that this is a much higher count. So this is nothing to do with the sort of balloon itself. The balloon is just a convenient way of collecting the dust. You could do this with a vacuum cleaner and a filter. I think I've seen that suggested, but this is just the easiest. So it's important just to remind your class it's not to do with the balloon, it's to do with the dust that the balloons have collected. I would hate anyone to go away with the idea that balloons are radioactive, okay? But it's just amazing to me how much higher than background this count really is. I've got 10 seconds left and then we'll take a stop. There we go. 5, 4, 3, 2, 1, stop. Wow, okay, right. That's 131 counts in the minute compared to 17 before. So that is that's about what? 6, 7 times background, yeah? What could you do with this? What does this tell us? Well, number one, it shows your pupils that radioactivity is real, it's all around us. And this is a real demonstration of real radioactivity going along right there. What else could you do with it? Well, if you did this at the beginning of the lesson, then at the end of the lesson, about 40 minutes later, you could take another reading and you would find that the activity had dropped because some of the radioactive material will decay. And about half of it will decay in about 40 minutes. Slight caveat, because it's a mixture of radioactive isotopes on that balloon, it's not going to be a true half-life, but it's not too bad. You do get a curve. And finally, I just find this amazing. When I was told about this demonstration, I thought that can't possibly be true. It must be a hoax. But it's real. Try it for yourself. All you need is a Geiger counter and a balloon, and you can see this happen for yourself. I hope you find this useful with your classes.